Hi everyone, and welcome to today's tutorial. We will be solving the LeetCode problem is subsequence. Well, this problem presents us with an interesting challenge. Well, given two strings S and T, we need to determine whether S is a subsequence of T or not. A subsequence is a new string that is formed from the original string by deleting some or none of the characters without disturbing the relative positions of the remaining characters. So our solution employs a powerful two-pointer technique, which allows us to traverse both strings simultaneously, comparing characters and maintaining the relative order. And by the end of this video, you will be equipped with the necessary tools to confidently tackle similar problems and expand your programming prowess. So without further ado, let's get started. Well, to solve this problem efficiently, we need to employ a powerful technique known as the two-pointer approach. This approach utilizes two pointers, I and J, which traverse the characters of S and T respectively, enabling us to compare them and maintain the relative order. Our solution relies on the fact that for S to be a subsequence of T, all characters in S must appear in T in the same order. By iterating through both strings simultaneously, we can determine if this condition is met. We start with the initial positions of the pointers I and J, and pointing to the first characters of S and T respectively. Then we move the pointers forward, comparing the characters at their current positions. And if a character in S matches the character in T, it indicates a potential character in the subsequence. And we increment the I pointer to move to the next character in S while keeping the J pointer unchanged. This way, we maintain the order of characters in S that we have already found in T. And after each iteration, we always move the J pointer to the next character in T, regardless of whether there was a match or not. This ensures that we explore all possible characters in T that could potentially be part of the subsequence. And we continue this process until we reach the end of either S or T. And if we successfully reach the end of S, it means all characters in S were found in T in the same order, confirming that S is a subsequence of T. And otherwise, if we reach the end of T first, it implies that we couldn't find all the characters of S in T, and thus S is not a subsequence. Now let's dive into the code and understand how our solution for the is subsequence problem works. First, we define a function called isSubsequence that takes two input string arguments, S and T, and this function will return a Boolean value indicating whether S is a subsequence of T. And inside the function, we initialize two pointers, I and J, and both set to 0. And these pointers will help us traverse the characters of S and T respectively. And next, we enter a while loop that continues as long as both I and J are within the bounds of their respective strings, S and T. And this loop will compare characters at the corresponding indices. And inside the loop, we check if the character at index I in S is equal to the character at index J in T. And if they match, it means we have found a common character in both S and T. And in that case, we increment I to move the pointer in S to the next character, maintaining the relative order. And after each iteration, regardless of whether the characters match or not, we always increment J to move the pointer in T to the next character. And this ensures that we explore all possible characters in T that could potentially be part of the subsequence. And we continue this comparison and traversal until we reach the end of either S or T. And once the loop ends, we check if we have reached the end of S by comparing I with the length of S. If they are equal, it means all characters in S were found in the same order in T, and we can conclude that S is a subsequence of T. In this case, we return true from the function. On the other hand, if I is not equal to the length of S, it means either not all characters in S were found or the order was not maintained. And in this case, we return false, indicating that S is not a subsequence of T. By using this elegant two-pointer approach, we efficiently traverse both strings and check for the presence of S as a subsequence within T. And now, let's dive into the time and space complexities of our solution. Understanding these complexities will provide insights into the efficiency and scalability of our solution. And in our solution, we employ a two-pointer approach, traversing both strings S and T simultaneously. And we iterate through the characters of both strings until we reach the end of either S or T. Therefore, the time complexity is proportional to the sum of the length of the input strings, length of S and length of T. And in other words, the time complexity can be expressed as the big O of length of S plus length of T. This linear time complexity indicates that our solution performs operations in direct proportion to the combined length of the input strings. It is worth noting that this time complexity is efficient, considering that we need to examine all characters in both strings to determine whether S is a subsequence of T. And moving on to the space complexity, our solution is commendable in terms of memory usage. It has a constant space requirement of big O of 1. And regardless of the size of the input strings, our solution only utilizes a few extra variables, namely the pointers I and J. And these variables store the indices of the current characters being compared. And the space used by these variables remains constant, irrespective of the input size, making our solution highly space efficient. And that wraps up our tutorial on solving the LeetCode problem is subsequence. I hope you found this tutorial insightful and empowering as we explored an efficient solution using the two-pointer technique in Python 3. And remember, the two-pointer technique is a powerful tool to compare elements in different sequences while maintaining relative order. And understanding this technique will not only help you solve the subsequence problem, but also tackle a wide range of other related problems efficiently. And the more problems you solve and the more techniques you learn, the more confident and proficient you will become. And if you have any questions, please leave a comment, and also please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Happy coding, and thanks for watching. Goodbye.